Hey guys, this is Mrs. Harbin, and this is another Algebra 2 video. Today we are looking at section 1.5, applying equations. We can learn all that we want to learn about equations and simplifying equations, but it really does us no good if we don't have any real-world application. If we can't use this out in the world that God created, what's the point? So today we're going to look at some applications. Speaking of applications, our biblical application is this. God is concerned about numbers. He created them for our use to help us be organized and orderly. He gave us the command to take care of this earth, and He gave us math as one of the many ways that we can use what He created in an organized, orderly fashion to care for His creation. Our lesson objective is this. The student you will solve problems involving number and angle relationships. Write an equation using one variable and do not solve. So if we wanted to write an equation to solve this problem, the rate at which Bryce traveled a distance of 156 miles in 3 hours. If you're curious to know the rate, let's say Bryce is driving home. He drives 156 miles in 3 hours. His parents want to know how fast or how slow he was driving. We can use this equation. Remember, rate times time equals distance. So using that equation and plugging in what we know the time was 3, our distance is 156, and now we just need to solve for the rate. Write an equation using one variable. Do not solve. A room has a length 3 feet longer than its width and a perimeter of 78 feet. Well, in order to write this equation, you're going to have to remember the equation for perimeter. And perimeter is we just add up all the sides. So it's 2 times the width plus 2 times the length. If we draw a picture of this, we see the width of the room is marked by W, and the length is just 3 feet longer than the width. So we've got 2 different sides, but both of them have the same variable, W and W plus 3. Plugging that into our perimeter equation, we get 4W plus 6 equals 78. Write an equation using one variable and do not solve. The original cost of a dress purchased for $29.99 at 40% off. See if you can write an equation, pause the video, come back and check your work. If it's 40% off, we're going to remember this equation. Percent times the whole equals the part. So 60% of the original cost is $29.99. Change that, get rid of our percent, and make it 0.6c equals $29.99. We get that 60 because if it was 40% off, we paid 60% of, remember that just means of, 60% of the original cost. When you're trying to solve a real-world application problem, the first thing you need to do is read. Carefully read the problem, noting important words, key phrases, and the type of problem. Represent unknown quantities algebraically. What I like to do when I read is translate it, if you will, into math. So if I see the word of, I'm taking of something, I'm thinking, okay, that's multiplying. Is signifies that I should put an equal sign there. And the things that I don't know, I'm going to represent with a letter, typically X or Y. However, I could give it any letter I choose. After reading carefully, I'm going to plan. I'm going to organize the information in a label, diagram, or table. Possibly draw a picture, come up with which formula is going to be most helpful to me. Then I'm going to solve. Writing an equation representing a relationship between the quantities that I know in the problem and solve for the unknown quantities. After that, I need to check my work. Take the solution, plug and chug it back into the original equation, and evaluate my answer. Is it reasonable? Does it make sense? Is it true? You'll be asked to do some problems with consecutive integers. If the first integer is represented with an n, how do we represent the next number, the second integer? If you said n plus 1, nice job. How would we write or represent the integer after that? The original number plus 2, n plus 2, nice job. Now, even in odd integers are 2 digits apart on the number line. So if the first integer is n, how would we represent the second odd integer? 2 digits later, we would take our original integer and add 2. How would we represent the third odd integer? If you said n plus 4, great job. Now, a couple of reminders about angles. The supplement of an angle measuring a degrees can be found by taking 180 minus a. Supplementary angles add up to straight lines. SSS stands for straight. Supplementary angles add up to 180 degrees. A complement of an angle measuring 80 degrees, complementary angles add up to 90 degrees. So we can find the complement of an angle by taking 90 minus that angle, A. Let's take a look at some numbers in a given ratio. 7:5 is expressed as 7x and 5x. 7 to 5 is expressed as 7x and 5x. Let's take a look at an example using all of these. The footprint of the Lincoln Memorial is a rectangle. Determine the memorial's dimensions and area if its perimeter is 620 feet, and its length to width ratio is 19 to 12. Well, reading carefully, what are we trying to find? It says we're trying to find the dimensions and area. These are the things we need to find. And what do we already know? We know the perimeter, or the distance around it, is 620. We also know it's a rectangle. Well, that's the very first step that we need to take, is read and figure out how we're going to, or what we're trying to find. We also know the ratio of the length to width, 19 to 12. So for every 19 feet long, it's 12 feet wide. Let's go ahead and create our plan. We're going to take 19 times whatever that x may be is our length, and 12, whatever our x may be, is the width. For every 19 feet, 1 foot, we have 12 1 foot. We just don't know how many feet we have. We're going to create a plan also by drawing a picture or a diagram. We know that area equals length times width, and our area, our sides, can be represented by 19x and 12x. So our area is going to be 19x times 12x. We're then also going to use the perimeter formula to solve. We knew that the perimeter already was a set number of 620. 2 times the length times 2 times the width equals the perimeter. By following our steps algebraically, we find out that x is 10 feet. We can plug that back into the length and the width, and then find the area. Our length is 190 feet, our width is 120 feet, and our area is 22,800 square feet. Another example where we might use some equations are motion problems. Rate times time equals distance. There are 3 main types of motion problems. The first type is round trip or pursuit problems, where distance 1 is equal to distance 2. Think of this as when you go to school. The distance from your house to school is equal to the distance from school to house, as long as you drive the same way both times. Or pursuit problems, where we both leave and we're headed the same direction. We're going to drive the same distance between the two of us. Motion in opposite directions problem can be thought of distance 1 plus distance 2 is equal to that total amount of distance covered. Or if we start at one place and we drive into opposite directions until we get to a set point, we still can add up our distances to find that total distance. The third type of distance problem is different distances, and that can be represented by distance 1 equals d2 plus n. Let's take a look at this problem. Ted and Jeff planned to leave at 9 a.m. to go camping. Jeff was delayed until 9:30 a.m. By driving an average of 8 miles an hour faster than Ted, Jeff arrived at the campground at noon, the same time as Ted. What was the average speed for both? So what we're trying to find out is their average speed, that rate. So it sounds like we're going to have to use that distance equals rate times time. Some other things that we know that what time they left. We know that Ted that Jeff had to drive 8 miles an hour faster than Ted, and that they both arrived at the same time. All right, let's draw ourselves a diagram. We have Ted and Jeff both covering the same amount of distance, just doing it in different times. That looks like that first distance problem, where we're both headed the same direction. We're going to label this chart with Ted's rate. And Jeff's rate is the same as Ted's, plus 8 miles an hour faster. For time, we know that Ted left at 9 and drove 3 hours. We know Jeff left half an hour late, so he only drove 2.5 hours. And we know that the distance that they covered is the same. 3RT for Ted, rate times time equals distance. And Jeff's rate times time is 2.5 times RT plus 8. Now, again, we know that these distances are the same, even though they're represented two different ways. But because they're the same, we can write an equation that sets them as the same. Once we've done that, we can solve for RT. We find out that R subscript T is 40 miles an hour. Well, that tells us Ted's speed. How do we find Jeff's speed? Plug it back in, and we find that he drove 8 miles an hour faster, so his total speed was 48 miles an hour. Try another one. Using the simple interest formula that I equals PRT, keep in mind that P stands for principal, the amount of money invested or borrowed. If you have money in a bank, it's the amount of money you put in the bank. Rate is the annual interest rate, the amount of money that you're earning. Banks do pay you to put money in their banks so that they can use that money until you need to withdraw it. Most banks locally have around a 1% interest, although you can find higher percent interest online. T is the time of the investment or the loan in years, how long you're keeping that money in the bank or invested. And L is the amount of interest, that's an I. I is the amount of interest that you receive on the investment or loan. It's how much the bank pays you for putting your money in their bank. Mr. Jameson makes $904.50 annually on a total of $9,500 invested into accounts, one paying 9% annual interest and the other paying 10.5% annual interest. How much is invested in each account? First of all, those are really high interest rates. You're going to have a hard time nowadays finding anybody paying that much interest. Money I have invested in just a savings account is around 2% interest. But let's go back to the problem. We want to know how much he has invested. First of all, he has two accounts for a total of $904.50. So let's make a chart to keep this information straight. He has two accounts. He has some amount of money in the 9% account and some amount of money in the other account. And we know that he has a total of $9,500. So $9,500 minus the first X will tell us how much is in this account. His rate, written as a decimal, because we don't use percents when we're putting these into equations, 9% is 0.09 and 10% is 0.105. The time for both is 1 year. And our interest is principal times rate times time. He earns, we know that when we add these together, we should get $904.50 because that is how much interest it told us that he earned this year. Solving for X, we find out that he has $6,200 invested in that first account. We could then plug that into $9,500 minus $6,200 to find out how much he has invested in the 10.5% account. And that ends up being $3,300 invested in the 10.5% account. A chemist has 12 kilograms of the 3% salt solution. How much water will need to be evaporated from this solution to obtain a 5% salt solution? So she's two ingredients, 3% salt solution and the water that is evaporating. So let's make a chart. In our 3% solution, we've got 12 kilograms, 3% salt. We don't know how much water. 0 salt in the water. And our 5% solution is going to be 12 minus W. And our percent of salt, we want to get to 0.04.